Okay, these notes are mole to mass conversions. Now, in real life, you're not going to be able to weigh out the amount of reactant you need or weigh out the amount of product that is formed in moles. Okay, you need to do the actual measuring in mass. This means you have to convert the moles of what you're trying to find into mass, or convert the moles of what you need into mass in grams. Once again, there's a two-step method and a one-step method for doing this, just like going from mass to moles. Only it's actually the opposite. Okay, so let's look at the two-step method. In this two-step method, you do a mole-to-mole conversion first. So you convert the number of moles of what you're given to the number of moles of what you need. Then the second step is you're going to convert the number of moles to mass by multiplying by molar mass. Now remember, you still have to put it in a picket fence or some sort of dimensional analysis. I've got to see those units cancel. If you don't, you won't get any points. Okay, so let's look at the first example. What mass in grams of iron is needed to produce 12.5 moles of the iron 3 oxide? Okay, just like before, I'm going to go ahead and put what I have. So I have, or what I want 12.5 moles. So that's technically the given, even though that's the product. We're trying to find the mass of iron. Okay, so we're actually given the mass of Fe2O3. Okay, and I also like to put down masses when I can, when I need to. So I don't know if I need the Fe2O3. I don't think I do, but I am going to put iron down, which is, so anytime you see a grams, here it's a question mark grams, but anytime you see a gram, most likely you're going to need the molar mass, at least going from mass to moles and moles to mass. So I'm going to put that there. Okay, so let's do the two-step process. So the first step is we need to go do the mole to mole. So we're going to start with 12.5 moles of Fe2O3, and on this next one, now remember, what you're given goes on bottom, what you need goes on top. We're given the Fe2O3, so we're going to put 2 mole of Fe2O3 here, and we're looking for the iron. So we're going to put 4 moles of Fe here. My moles of Fe2O3 cancel, and I'm left with moles of Fe. So when you do this, it's going to be 12.5 times 4 divided by 2. Okay? Which equals 25 moles of Fe. Now there's no rounding involved. Oops, sorry. 12.5 basically times 2 is 25. So at least this one doesn't come out of decimal, so you don't have to worry about rounding. Okay, I'm going to move it up a little bit. Okay, so now we're going to do the second one, which is you're going to take that 25 moles of Fe, and now we're going to convert it to grams by multiplying by molar mass. That means the 1 mole goes on bottom, and the 55.85 grams goes on top. Moles of Fe cancel, and then 25 times 55.85 equals 1396 grams of Fe. Pretty easy. Okay, now let's try it using the one-step method. Now the one-step method, we're going to use a double picket fence just like before. So once again, I'm going to go ahead and put my question mark grams, 55.85 grams per mole there, and my 12.5 moles here. Okay, so actually let me lift this up a bit. So we're going to use a double picket fence in this one. Now I will do another slide again where I do the dimensional analysis like I did going from mass to moles, okay, with just the either the parentheses or just the times, okay. I'd like to use picket fences, but hey. Now a lot of times I'll start out with a road map, but I think we can get this without the road map. It's still the 2 steps from the two-step method, except for you're just putting it in one picket fence. So the first step is doing a mole to mole conversion. So I'm going to write down 12.5 12.5 moles of Fe2O3 and 2 moles of Fe2O3 here and 4 moles of Fe. Now, instead of figuring out what that's equal to, I'm going to put the next step in, which is multiplying by molar mass. Well, that means the 1 mole of Fe is on bottom, and I know that because I have moles of Fe on top, and 55.85 grams of Fe. So everything cancels, and I'm going to put my line here. So now I have 12.5 times 4 times, oops, that's a 4 by the way, times 55.85 divided by 2. And when you do the math, it comes out to be 1396 grams of Fe. Same number. To me, this is easier because it's putting the 2 steps into one picket fence. It's a little less work. You don't have to write an intermediate step in there. Okay, so on the next one, I will show you the way with the times with the fractions and then with the parentheses. Okay, so this time let's go ahead and write the equation down again. So we have 4Fe plus, what is it, 3O2 yields 2Fe2, oops, O3. I'm going to put my amounts, grams, 55.85, and 12.5 moles. That's an O, by the way. Okay, so here we're going to start with the 12.5 moles of Fe2O3. Okay, and then I'm going to write a times. I'm going to put some things here. Well, I know my first step is a mole-to-mole conversion, so that tells me what to do. I need to do 2 moles of Fe2O3 and 4 moles of Fe. So my moles of Fe2O3 cancel. And next is my molar mass, which goes on top, 5.85 grams. Oh, I didn't put the grams here. Grams of Fe. Now remember, you have to have number, unit, substance. Number, unit, substance. If you don't, I count off. When you do the multiplication, it's still 12.5 times 4 times 55.85 divided by 2, which is 1396 grams of Fe. Now, if you don't like that way, if you like parentheses, just do this. Same thing. Means the same thing. Okay, so hopefully you got that. It's just a little different. It's just the opposite way of the mass to moles. So I guess I will see you tomorrow. Bye.